Hello, welcome back to 1.9 Introduction to Parent Functions. And again, I got it backwards. Yeah, I think it's textbook page 70 and PDF page 69. That's what happens when you cut and paste. We're going to look at problem 8 and problem number 9, which is graph the data and see if you can describe the parent function and whatever transformation that you might have. Now, like I did, I'm mixing up between drawing by hand and using Desmos. And you could probably tell I actually printed this by doing a screenshot of the grid from Desmos. And if you look at both of these, I tried to get this where it would match up. Notice that the y's go from -15 to +15, so I tried to go a little bit wider than that. And for this one, the numbers are like, from -1 to 1, so I tried to zoom in for that. So you notice that the scales are not the same for both. So be aware of that. All right, I'm just going to plot the points. -3 is -15. So this is -1, -2, -3, -4. -3 is -15, which is about right here. -1, -5, here's -1, -5 is about right here. And 0, 0, 1, 5, here's 1, 2, 3, 4, 5. 1, 5 is about right here. And 3, 15 is about right here. Well, I know it's hard to tell through the screen, so I'll try to do this. Yeah, that looks pretty straight. Those look like it's going to be a linear function. So my parent function is going to be f of x equals x. The family is going to be the linear family. Remember, this is the parent function, this is the family. And what transformation? So it's kind of hard to see because of the way I notice I scaled this out so I could like put it all in the same graph. It's kind of hard to eyeball the slope. I'm going 2 squares, or I'm going 4 squares to get to 2, but I'm going 5 squares to get to 10. So I've adjusted the scale. But I do know that the parent function would be just x. So what do I do if I have my parent function? The input is x. That means that the f of x is just going to be that number 1. What I do to go from 1 to 5, multiply by 5. 3 times 5 is 15. -1 times 5 is -5. So it looks like this is a vertical stretch by 5. And I could try to draw my parent function in there, but I think that would be confusing because of the scale change. All right, let's look at problem number 9. -3, -1. So again, this is 1, 2, 3, 4, -5. -3, -1 is right here. Look at how I stretch the scale out. Because I've got -1, -1/27, which is a really small number. -1, -1/27. That's, we could figure it out on the calculator. I don't think we need to. We just know that it's going to be like right about here. 0, 0 is right here. 1/27 is going to be right here. And then 3, 1, excuse me. 1, 2, 3. 3, 1 is going to be about right here. So it kind of looks like this one does this. And that reminds me of the cubic. So I think my parent function is going to be f of x equals x cubed. That's the cubic family. And if I make my table using the cubics, all right, and I don't really have room to squeeze it in, I'm just going to put it along the bottom, okay? So this would be the parent. -3 cubed is -27. -1 cubed is -1. 0 cubed is still 0. 1 cubed is 1, and 3 cubed is 27. So it looks like to go from here to there, I divided by -27. So probably my function g of x is going to be x cubed divided by 27. Which is weird, but still, that's what it is. Which means that it is a vertical compression by 1/27. which you didn't see because it wasn't on the screen. So there it is. All right, and that's it. That one's tricky. What I want you to get out of this is plot the data, see if it matches up with one of the parent functions that we know. Once you think it's that, say, try to figure out how, like compare, using arithmetic, compare negative 27 to negative 1, negative 1 to negative 1 over 27. Both times I'm dividing by 27. We'll see you in the next video.